All right, here's another probably a shorter type of question. And when I read through it the first time, I think there's a lot of this that we may be able to do without graphing calculator. So there may be some sort of variation on this for this year, and that would probably come in the functions that they give you, like g of x and h prime of x, maybe something along the lines of some trig or something else in there. But we may get something definitely where we have a chart. We got to be able to read the charts and find derivatives. Okay, so like always, pause it here, see how much of this you could do. I'd say maybe about 10 minutes or so we could be doing something like this. All right, for part A then, we have our chart. We're told that g is a function 2x minus 1 times f of x. And we want to find g prime 3, the derivative of g evaluated at 3. So we need to find the derivative. So that's all we're really testing here. But we do have some product rules. So we have the first part and the second part here. So we're going to use the product rule. And that means that g prime of x is the derivative of the first times the second plus the first times the derivative of the second. So that is really just a quick product rule. We want g prime evaluated at 3, so we're just going to substitute that in. 2 times 3 minus 1 times f prime of 3. Okay, so now we're going to go to our chart and get this solution. So we have 2 times f of 3. So f of 3 is 7 plus, we can do all of this. That is 6 minus 1, that is 5. And then f prime of 3 is minus 1. So we're going to get 14. This becomes minus 5 or 9. So g prime of 3 is 9. For part B, we have another function h. This time h is f evaluated at f of x, and we want h prime of 4. So now we're looking at the chain rule. We have an inside function and an outside function, right? So we have the inside function f and we have the outside function f. So we're going to do some chain rule here. So h prime of x, chain rule says the derivative of the outside times the derivative of the inside. So now we are going to just go to our chart again and evaluate this because we want h prime evaluated at 4. So that becomes f prime of f of 4 times f prime of 4. So this is f prime. F of 4 is 3 times f prime of 4 is 6. So that's times 6. Well, we still got to do this. F prime of 3 is negative 1. So negative 1 times 6. So h prime of 4 is actually negative 6. All right, for part C now we have an integral. We want to find the value of the integral from 1 to 5 of x plus f double prime x dx. Okay, so we're going to be looking at the fundamental theorem of calculus. Okay, so the fundamental theorem of calculus, just remember, says that, does not say that. Fundamental theorem of calculus says the integral from a to b of some function is equal to the antiderivative of that function at b minus the antiderivative of that function at a. So this is what we're looking for here, okay? All right, so let's apply it to our part here. So I'm just going to get rid of that part. Okay, so ours says the integral from 1 to 5 of x plus f double prime of x. Well, I'm going to start first by splitting this up. This becomes from 1 to 5 of x dx plus the antiderivative of 1 to 5, or the integral from 1 to 5 of f double prime x dx. So I'm going to split up the two parts. Now we can use our power rule for antiderivatives. So this side here becomes x squared. We add 1 to the exponent and divide by the new exponent. And we're going to evaluate that from 1 to 5. Plus, let's do this part over here. And it looks different, but if we take the antiderivative of the second derivative, that just gets us back to the first derivative. And we're going to evaluate that from 1 to 5. Okay, so let's slide this up a little bit. I'll slide all of this. Okay, so let's continue on in the first part. This just becomes 5 squared over 2 minus 1 squared over 2 plus this whole part becomes f prime of 5 minus f prime at 1. Top minus bottom. So 25 halves minus 1 half plus, I got to go to my chart, so let's bring my chart back down here. And I know it's kind of in behind, but f prime of 5, see, f prime of 5 is 2. So that's 2 minus f prime of 1 is 5. Okay, so let's finish this off. 25 halves minus 1 half. That's 24 halves, which is 12. This whole thing here becomes minus 3. So we are at 9. Now in part D, we're asked, is there a value c between 3 and 4 such that the second derivative is equal to 7? So this one is the interpretation. We need to understand what it is they're asking us for. Now when we are finding a c between another value, that was like the intermediate value theorem and the mean value theorem. That's what we're actually looking for here. So let's go back. We are looking at the mean value theorem for integrals, or that idea that says 1 over b minus a from a to b of f of x dx, some function, is equal to f of c. Really saying that at some point through this function, there is a value c where it is going to take on the value of the mean of that function. That's what we're looking for here. So is there this value c such that all of this on the left is equal to 7? Well, let's go ahead and substitute some of our numbers because we're looking between 3 and 4. So we're going to have 4, 3, from 3 to 4 of f double prime x dx. So that was our function, f double prime x, and we want that to equal 7. So we want to know, is there something here where that is going to equal 7? That's what we're trying to prove. So let's move this up. I actually want to keep that. I'm going to slide all this rest of it up. I'm going to keep this down at the bottom for us here. Okay, so now this becomes 1 over 1. This whole thing is just 1 over 1, so I don't really need to write that. This becomes f prime of x. That's the antiderivative of f double prime. We're going to evaluate that from 3 to 4, and we're going to see if that equals 7. If that equals 7, then there is a c value such that f double prime evaluated at c is equal to 7. So this becomes f prime of 4 top minus the bottom is equal to 7. Well, f prime of 4 is 6 minus f prime of 3 is negative 1. And 6 minus negative 1, that becomes positive. 6 plus 1 is in fact 7. So there is a value, f double prime c is equal to 7. There is a value such that the second derivative evaluated at c is equal to 7. And we've justified our answer using our mean value theorem.